This is lecture 1. Last time was lecture 0. And Kevin's going to be giving this lecture. We trade off. We kind of ping pong back and forth. I think Kevin does the next one too, and then I do the ones following that. This one is concentrating on Objective-C, the language. And then we'll start talking about some of the more esoteric aspects of Objective-C and OSX and iOS development next time.
Okay, so let's jump right in. If we have administrative questions, we'll deal with those at the end. So today is the first of 2 lectures on the basics of Objective-C, which is the language that Mac and iOS apps are written in. So just to begin, I'm going to give a little history about Objective-C. It was started in the 80s by 2 gentlemen, Brad Cox and Tom Love, at their company Stepstone. They had just seen Smalltalk, which was this kind of really innovative object-oriented language, and they really liked a lot of features of Smalltalk. They also really liked the portability of C, and so they wanted to marry those two to have something, an object-oriented language that you can write once and compile anywhere. So they initially wrote Objective-C as a pre-compiler on top of C. So they added Smalltalk-style syntax to C. In 1988, Next licensed Objective-C from Stepstone and used Objective-C to build its Next Step operating system, which became the foundation of OS X when Apple bought Next in 1996. And it's been used to write OS X and iOS pretty much ever since. So some features that Objective-C has, like I said, it's actually a simple extension to C, so that means any legal C code can be compiled by the Objective-C compiler. Because it is compiled and compiles down to C, it has that low-level efficiency and interoperability that C provides. It has a really dynamic runtime. I'll address that later, but it's a really very dynamic runtime system. A lot of library support for the runtime. It's statically typed like C, but there is an optional non-static type that you can attach to things if you want to have really dynamic types. It's a single inheritance object-oriented language, so it's not like C++ where you have multiple inheritance. It's more like Java where you have a single parent class and you can fulfill multiple interfaces, or as Objective-C calls them, protocols. And we'll discuss those, I think, next time. So like I said, Objective-C has a very dynamic runtime. Objective-C objects are always allocated on the heap, just like I think with Java, all objects are heap objects. And what's kind of unique about Objective-C is that all method calls are resolved at runtime, which gives you a lot of dynamism, because you can swap out objects under the hood and it will message the new object. All those method calls are done really at runtime, basically based on the string of the method that you're calling. Okay, so before I get too far in, how many people have never programmed in an object-oriented language before? Nobody. Okay, so all these terms should seem familiar to you. So we know what a class is. It's the blueprint for an object. An instance is one particular allocation of that blueprint. Methods are functions that objects can do, and instance variables are the data they contain. Objective-C sort of has a somewhat unique object system. It takes a bit of revising your thinking to think about how Objective-C messaging actually works. Alan Kay, when he was devising Smalltalk, said he thought of objects as biological cells or computers on a network that can only communicate with each other via messages. And so that's the basis of Smalltalk, is that objects pass messages back and forth between each other, rather than the C++ model of directly invoking a piece of code that's been bound already at compile time. So as a comparison, a procedural language has functions operating on data, so this is something like C, whereas an object-oriented language has objects that communicate with messages, and we'll see what those look like in a bit. Abstractly, as you're probably familiar, an object has internal state, which is generally kept private, and then you have methods that allow you to access parts of that internal state that other objects can call those methods. But usually, the idea is that you can't directly, an external object can't directly manipulate the internal state of the object. If you want to make those manipulations, those need to be done through methods. Everybody familiar with that idea? Okay, and we often call that data encapsulation. So this is an example of 2 objects interacting in Objective-C. So we have this lower left object, which sends a message to this other object. and possibly gets back a reply if that method returns some value. It might not, but if it returns a value, then it gets back a response from that object. But as you can see, these objects never directly contact the internal state of the object. They just send a message. Literally, just basically they send a string across to the other object saying, "Here's the thing I want you to do. You know, I'm saying hello. You're saying hello back." Some more object-oriented terminology. We have the object-oriented languages often talk about the idea of polymorphism, which is different objects that have the same interface. So you can imagine if you have a drawing program, you have a bunch of different shapes in this drawing program. They all know how to be drawn. So polymorphism is the idea that as long as you have an object that you can draw, you don't really care what the object is. It's just, it's a thing that can draw. And that's a polymorphic idea. That it's just something, you're more interested in what the thing can do than what it actually is. And as you probably know, inheritance is a hierarchy of classes. Subclasses can inherit behavior from their parent, and if they want to, they can add additional behavior or change the behavior of their parent by overriding those methods. Is that clear with everybody? Did everybody remember that? Okay, so here are the declarations of some Objective-C messages. Just to kind of give you an idea, I'll talk about some of these in more detail, but you have instance methods, which are messages that require you to have an actual allocated instance of an object to call, and then you have class methods, which do not require an instance of the object to be called. You can just message the class directly. So people tend to struggle with the syntax of Objective-C messages because they're much different than pretty much any other language I've ever seen. So we're going to try to do this very slowly and get a lot of examples of what messages look like in Objective-C, because it's really important that you know how to call messages, because every time you want to do something with an object in Objective-C, you have to call a message. So this is one kind of message where we have the way it works is you start with a left square bracket, meaning I'm about to call a message. The first thing you put is the object to which you want to send the message, often called the receiver, followed by a space, and then the name of the message or method that you want to call, closing out the brackets. Does that make sense? That's a simple no argument. That there's just, this is maybe print, just some method that doesn't take in any object, doesn't take in any parameters. This is an example of a one-parameter method in Objective-C. So again, we start with the left square bracket. The next thing is the receiver, the object that we're sending the message to. Then, this is where people really get tripped up, is when you have parameters to messages. So again, you have the text of the message, followed by a colon, indicating that the next thing is going to be a parameter, and then the actual parameter that you want to pass in. I'll have some more concrete examples later. Where it gets really odd is when you have more than one parameter, and this is what people really dislike this at first. But it actually makes Objective-C code extremely readable, being able to split the name of the message across the parameters. So the name of this message is message more message, but we have two locations to place parameters, and those are indicated by the locations of those are indicated by the colons. Yes.
What if you don't have the second message?
The second, like you're talking about more message. More message actually is optional. The colon is not. If you want, you have to have a colon to indicate that there's a parameter. It's not considered Objective-C style to not include this parameter naming. But if you wanted to, you could. But it's the Objective-C style to anytime there's a colon that you put some text describing what that argument's supposed to be. The practical upshot of that is that once you have a message call, it actually is really readable, because then you don't have to remember that the X parameter is first and the Y parameter is second. It's like you know that based on the name of the message that X is first and then Y is second, because that's what built into the message name. Yeah.
So if receiver is the object, then which one's the method again? If message is the...
Yeah. So this entire thing, message arg1 more message arg2, that's the entirety of the message call.
Yeah.
The name of the message is message colon more message colon. And then the colons indicate that at the points where the colons are, I'm passing in other objects or other values as operand.
Well, what indicates the method that's being called?
The text of the idea. In some sense, it's the space. Is kind of the apply of a message. but we surround it in square brackets to make it easier to see that we're. It's worth noting that Smalltalk doesn't have the square brackets, so that makes reading nested method calls really hard in Smalltalk. So Objective-C added the square brackets to make nested calls easier, but this entire thing is a message call to the object named receiver, the object receiver.
It's easier instead of thinking of it as trying to think of it as message with these parameters is to think of the whole thing as the message. The whole thing is the method. The whole thing is message more message. That's the entire piece. It's not message with a parameter more message. It's the whole thing.
Yeah, and I'll have some more examples further on that have less abstract and arcane names for the messages. So hopefully that can answer some of those weird questions that you have. So here, just so you guys have, if you're familiar with Java, I'm just going to make some comparisons so that we can kind of get a sense of kind of what's the mapping between a Java method call and an Objective-C method call. So here's a simple no-argument Objective-C message call. Again, we have the left square bracket, the receiver of the message, followed by space, then the message I want to call. In Java, that'd be something like receiver.message, paren paren. That should be pretty obvious. Any questions about that? Okay, so here is a one-argument method in Objective-C. Again, we have left bracket, the object we want to send the message to. And it's worth noting that this object here doesn't have to be the literal text of a variable name. As long as it's something that resolves to an object, you can call a method on it. So you can have nested method calls, and I think I have an example of that later. In Java, that'd be something like receiver.message of argument. Does that make sense? Okay. The complicated one for most people is the two-parameter one. Obviously, Java doesn't have this pseudo parameter naming. So what the name of the method is a little bit fuzzy. It might be something like receiver.message more message or receiver.message of arg1 arg2. But again, it's just Objective-C just adds the ability to you pseudo name each of the parameters and you embed that inside of the actual call of the method rather than just the definition of the method. Okay, so that's what it looks like to call Objective-C methods. Here's some slightly more concrete examples. So let's assume that we've defined a person class, and I have a person object. So this is a person variable, and for example, that person class might have an age. We want to know how old the person is. So let's suppose that returns an integer value. Then I can just say left paren person message is age, and that call will return an integer value of the age of the person. Cool? Okay, like I've mentioned before, these calls can be nested. So if our person class has a method father that returns another person object that's the father of that person, now we have another person object, we can send a message to that. And so we can nest these method calls. Does that make sense? Okay, and here is a parameter, or a method with one parameter. So we have some array that we want to add an object to. We say add object, colon, and then the object we want to add to the array. Okay, and here's an example of a two-parameter method. We have some array that we want to insert an object at a particular index. We can say insert object, the object we want to insert, at index, the index we want to insert it at. Any questions about that? So the name of this message here is insert object colon at index colon. But it's easier to think about the entire message call as insert object, the object, at index, the index.
Are the messages supposed to be initialized somewhere before?
Yeah, I haven't talked about yet how to declare messages. I'll talk about that in a second.
Would the insert object method have a variety of sub-messages? Just any message
well, those would all be viewed as independent messages. Like you're saying, insert object, some other parameter. It would be a totally independent method. So that they would be viewed as distinct message calls and distinct messages. Yeah.
And also, like, you did initialize the person, right? Before
Yeah, again, assume we know how to initialize objects.
And array as well.
Yeah. Again, these are just just showing what calls look like. I haven't showed you the details of how to actually make objects and define them. We'll get there though. Yeah.
Is the star the convention for declaring variables?
I'll talk about it in a second. We'll get there. Okay, so here's another slightly more interesting method. It's a method on a base class called NSString, which is the string class, and there's a method string with format that allows you to do a printf style format string, which takes it's a variadic argument is what it's called. So it takes the string you want to format into, and then any objects you want to add to that format string. So Objective-C messages can support variadic arguments as well. Okay, so how do you declare an Objective-C method? So Objective-C methods, you have to declare them, and then you also have to define them, and we'll talk about those in two pieces. Declaring a method, I'll just go over the pieces. The first piece is you have to start with either a minus sign or a plus sign. The minus sign indicates I'm defining an instance method. The plus sign indicates I'm defining a class method. Remember that class methods you don't require an instance of the class to call the method, whereas the minus sign, you need to have a particular allocated instance of the class to call the method. Yes? I'm trying. Okay, sorry about that. It's a big room. Okay, so we start with a minus sign or a plus sign that indicates whether or not the method is an instance method or a class method. The next is the return type surrounded in parentheses. So in this case, we're returning an integer, and then the message, the name of the message, and then semicolon to say I've declared this message. Does that make sense? Any questions about declaring them? This is a pretty simple example. It's just a no parameter method, but it's a good example to start. Okay, so an equivalent expression in Java might be something like public int number of children paren, then curly braces the body of the method. Java, of course, doesn't really have a notion of declaring a method without defining it, but Objective-C does, and you'll see why we need that. So that's an example of declaring a no parameter method in Objective-C. Does that make sense? Okay, so a slightly more complicated example. Now we're going to declare a class method that takes two parameters, and this is maybe some number class that converts feet to inches and inches to feet and back and forth. So we say plus sign to indicate that we're defining a class method. So again, that means we don't need an instance of the class. We can just call it on the class itself. Again, we have the return type in parentheses, and then again, this is the name of the message. So it's and then we have the parameters with their types. So the way to define it is name of the message colon the parameter with its type, and then if you have another parameter, more message colon another parameter name with its type. If you have more message colon, and so on, into as many as you want. Any questions about that? What I found tends to trip people up is that the declaration of a method looks rather different than a method call. You just kind of have to get used to it. But if you think about this entire thing as the message call, it's really not that different. The only difference is that in the declaration we have to specify what the type is. Okay, so a similar idea in Java would be something like inches for feet in inches, paren int feet in inches, with the static keyword indicating class method, and then the return type of int. Does that comparison make sense? Yeah.
So you have to split up the names into.
Yeah, I mean, like I said, you can omit the additional part of the message, but as long as you include the colon. It's not the Objective-C style to do it that way. And the nice thing about this is that it makes Objective-C really readable. So if I want to find how many inches are in 12 foot 10 inches, I'd say my class inches for feet 12 and inches 10. And then it's really obvious that I'm saying 12 feet and 10 inches, however many inches that is. And then it makes Objective-C really verbose at times. You can have really long method calls. Like that NSBitmap image rep method call, but it makes it really readable. Yeah.
So if you have 6 parameters, are you expected to break it up into 6?
Yeah. So if you have 6 parameters, the expectation is that you would have 6 messages followed by a colon. and that I want to show just to give you an example of how that can go really take that to the limit. Air Bears.
Yeah, just one thing to mention, Xcode has a lot of great autocomplete features, so while this seems like a real pain to write, when you're actually working with it, it's really convenient because you don't have to memorize the orders of the parameters to all these different methods. You just start typing it in, it prompts you, you're tabbing through, and it's basically telling you what to put in. It's really convenient.
When it auto completes a full message, including the brackets and everything, tab will take you from parameter to parameter. So it's really fluid. So be verbose.
Okay, why? That's really weird. First law of demos, it always goes wrong when you're doing it live. Yeah. All right, what's up with Air Bears? Okay, fine, I'll do it in the documentation browser. Oh, there you are. Okay. Okay, sorry about that. NS bitmap image rep. So this is a class if you need to make image files and you need a bitmap image representation. Here is an extremely long method. Init with bitmap, data planes, pixels wide, pixels high, bits per sample, samples per pixel, has alpha, is planar, color space name, bitmap format, bytes per row, bytes per pixel. So if this method just had a very short name and then a big list of parameters, would you be able to remember which one is which? I don't think so. There's about 7 parameters. I don't think I'd be able to remember which one is which. But if you have auto-completion and pseudo-named parameters, just by looking at the auto-completed method call, you know which parameters to insert in which locations. So it's really quite helpful, if verbose.
Oh, quick question. It's like argument 1, the sequence that they're going through is like third method, or can I just swap them around? Whatever?
No, they can't be reordered. The name of the message is fixed in order. So it's not like Python keyword arguments where you can rearrange the order of them. They do have to be played in the name of the message. And that's a implementation detail that they had to do it that way.
So let's say like I did create that method with 7 arguments, right? And like I need the same only 3 arguments from that method. Do I have to create a new one?
You'd have to create a new one, or write that method in such a way that you can take some don't care values, and just a lot of those factory methods like that. You don't need all the parameters, but Apple says, okay, if you want to use, for some of these are optional in the sense that you can just pass in some default values like null, and it will just kind of ignore them. Okay, so how do we define an Objective-C class? An Objective-C class definition is split up into 2 files. There is a public header file, so the idea is that the public header is what any other class can see about this class that you're interested in. So this is where you export, define all of your public methods and define all of your instance variables. And the implementation detail file is where you actually put the bodies of all of your methods. So this is an example Objective-C header file for my image class for some small 16 by 16 pixel images. So let's kind of just go through the pieces of this file. At the top, we import Cocoa, which is the library that Apple provides that has all of the foundation classes built into it, so that way we can use Cocoa classes such as NSObject, NSString, and all the other classes that ship with the development kit. The first line at the @interface directive, we have the name of the class we're defining, followed by a colon, followed by the superclass, which interestingly is optional. I highly recommend not leaving off the superclass because you can define your own base class if you want, but that means that everything like memory management and all that other behavior you lose because you're defining your own root class. So not that all that's implemented in the root class that's already built in. So but it's just as an aside, you can omit that if you want and define your own base class. Okay, after the interface line, inside curly braces are declarations of all of your instance variables. So in this case, we have a string variable called name and a double character array named pixels. Outside of the curly braces, but before the @end directive, are declarations of your public methods. And these are just declarations like we saw before. Any questions about what goes into a header file? Yeah.
Is there a way to declare private methods?
Yeah. There's a few ways. There's a few ways to do it. One is to not declare it in the header file and just to provide a definition for it in the implementation file. Sometimes that'll generate a compiler warning because it compiles it from top to bottom, and if you don't have a declaration, there is a formal way called a class continuation to define private methods, but I won't go into that because it's more advanced. But you can do it, and it's pretty common to have private methods. And it's worth noting that instance variables in Objective-C are by default private. There are some compiler directives for you to make instance variables public or something like that. I highly recommend you do not do that. It's bad style to have public instance variables. So by default, no object can directly manipulate instance variables, so it's perfectly fine to declare them in the public header, and nobody can manipulate them directly. Okay, an implementation file, the first line, we have to import the header so that we know which class we're providing the implementation for. Then between @implementation, the name of the class, and @end, you provide bodies for those methods. And so these look the same as method declarations, except instead of terminating with a semicolon, we provide a body inside of curly braces. Any questions about implementation files? Okay.
Actually, I have a question.
Yeah.
So implementation files don't have to import like coco.h or like
no,
the
and the reason they don't need to import it is because they import the header, which in turn imports the library.
Okay, so they kind of cascade down.
Mm-hmm. Yeah, and it's worth noting if you're used to C and you're used to using pound include, pound import is slightly smarter than pound include and won't cause the class to be compiled 50 times if you import it 50 times. So the Objective-C style is to use pound include for Objective-C files, so that way you don't triple compile classes and waste time in compilation. Okay, so that was kind of abstract and high level. Let's actually do a demo of me writing an Objective-C class. Okay, so I'm going to create a new Objective-C class. I'm going to call it fraction. All right, can you guys see that in the back okay? Is that big enough? Cool. Okay, so I created a new subclass of NSObject for using Xcode, and it's provided me with a very skeleton file that has a header that has just the interface declaration, and the implementation file imports the header and has nothing in it. So let's start with the instance variables for our class. What instance variables does a fraction class need? There's really two things a fraction needs. It needs a numerator and a denominator, right? So let's store those in integer variables. Okay, so now we've said that this class has a numerator and denominator, and when we allocate instances of this class, it will make room for those instance variables. So let's define some simple methods for our fraction class. So once we have a fraction, we probably want to be able to ask it for what the numerator and denominator currently are. So let's have a method called numerator and a method called denominator, and have those return the corresponding values. So what's the return type of the method going to be? Int, because we're returning the value. And I'm just going to call it numerator. Note that it's perfectly okay to have methods and instance variables that use the same name. They're essentially in different namespaces, so there's no concern about them colliding. And the Objective-C convention, if you're used to Java, where you would probably call this get numerator, the Objective-C convention is to not include the get for the getter, just to say the name of the thing you want. And similarly, we'll have denominator to get the denominator out. We probably also want to be able to assign a numerator denominator. So these methods don't need to return anything, so we'll just say void for the return type and call it set numerator. And then I say a colon saying I'm going to pass in a parameter, and then what am I going to type next? Int, because I'm expecting to receive an integer, and I'll call it numerator or something. It's fine. Okay, and similarly we'll have set denominator. And maybe we want to be able to reduce the fraction to the lowest terms, and we can just have it modify the object, so we can do something like reduce. Okay? Any questions about these methods? These should be declarations. Yes?
Is void optional?
No, you must specify the return type. It doesn't. It will not default to void, for example. Okay, so those are, for now, all the methods we need. Let's go into the class implementation and provide bodies for some of these methods. So again, if we want to implement the method numerator, we just include the definition for it, and as you notice, Xcode hopefully starts autocomplete it. Xcode 4 has been doing this weird thing that it won't autocomplete some things until you close and reopen the file. I'm not sure what's up with that, but anyway. Yeah. But anyway, the body of this should be pretty straightforward, right? We're just going to return the instance variable numerator. And similarly, denominator will just return that instance variable. Okay, and then we'll write our setters. So set numerator, int numerator. Now here, in the header, I named the variable numerator. But we really don't want the variable in the method definition to be numerator, because the instance variable is also named numerator, and it won't be clear which one is which. So we can just name it something else. It's totally okay that the name of the variable is not the same as in the header. The reality is the compiler doesn't care what the name of the variable is as long as there is a parameter there. Okay, so then I can just say numerator equals numer. And similarly for the denominator.
Is there a this keyword or something similar?
It's self, but we'll see that later, I think. And again, I'll just call this denom. Okay, and I'll partially implement the slightly more interesting reduce method. So I'm going to assume that we have a function that returns. So the way you reduce a fraction to lowest terms is you get the greatest common divisor of the top and bottom and divide both by that value. I'm going to pretend I have a function that does that. And notice that this is just a C function. So you can it's perfectly legal to mix Objective-C and C calls within an Objective-C class. So I'm going to assume that we have a function that does that, and then I can just say numerator divide equal GCD. Denominator divide equal GCD. And that will reduce the fraction to the lowest terms. Any questions about those methods? Okay. Okay, and I think I have slides that do those same things, so you can look at those for your reference. Okay, so how do you declare variables in Objective-C? Well, they're declared pretty much exactly just like in C. Variables must be declared like in C. So you have all the built-in types like from C. You have ints, you have floats, you have doubles, you have chairs, you have all of those, or chars, however you want to pronounce it. And then you also have Objective-C objects. Important announcement. Objective-C objects are always pointers. They are always pointers. They're always pointers. You're going to get a lot of weird compiler errors if you don't make your objects pointers. And the reason they're pointers is because objects are allocated on the heap, so you need a pointer to where it lives on the heap. Objective-C, so C has C strings, which are just character arrays. Objective-C introduces its own string type, and you can do literal strings that basically are typed exactly like literal C strings, except that they're prepended by an @ sign to indicate that this is an Objective-C NS string object. The difference is that a character array is not an object. You can't send messages to a character array, but you can send messages to an NS string because it's an object. Does that make sense? Okay, so I mentioned earlier that Objective-C has optional static typing. So normally you statically type your objects so that way you know the exact type of all of your objects. There is an optional dynamic type called id that just means any object type. And note that that's any object type, so it won't type, for example, literals or built-in values like ints and floats. Or maybe it will. I don't remember. But I think it's just typed F to be void star. I think that's what it is, which is just any pointer object basically. So, but if you want to have optional typing, then you can. That's really useful if, for example, you have an array full of objects of mixed types, and you don't know what type is going to come out of the array. You can just say it's an object, and then just call it id. And hopefully the method you call in it makes sense. But that's a nice way to not have to worry about doing a bunch of type checking on the objects. You can just say it's an object. Okay, go with it. So like I mentioned earlier, Objective-C methods are bound at runtime, so it uses what's called dynamic binding. Methods don't actually, which object is going to receive a particular message doesn't get determined until you're actually running and the method actually gets sent by the sending object, which is really quite useful because that means you can do some sneaky things like literally swap out the code for the body of a method and still have it call the updated code, or swap out the object underneath and call it on the new object. So it's really quite dynamic. Like method dispatch, Objective-C objects can know about themselves, and that's all again done at runtime. So you can ask an object what its class is. You can ask an object a lot of other type-related information at runtime to figure out if you really need to know the type of it. You can ask it for what its type is. Generally, it's considered that asking an object for its type and doing something based on the type is considered bad style. But there are cases where you need to do that, and Objective-C has a really clean way for you to figure out the type of the object that you're dealing with. And most of these methods are defined on NS objects. So if you want to look at them, you can look at the class definition for NS object to take a look at some of those methods. So, here's some. So, and one example is kind of class, which will return a Boolean value, yes or no, whether or not it is a member of that kind of class or any subtype of that class. Is member of class is slightly more restrictive. It's only that kind of class. It excludes subclasses. Responds to selector, I'm going to kind of gloss over that, but it's the idea is, does this object respond to this message? If I send this message to this object, will it be able to give me an answer? And that's but we'll talk about selectors next time, I believe. Sorry, these are all kind of scattered things I just wanted to cover at the end, basically. So NSLog is a really useful function built into Foundation. It's quite useful for debugging if you're a printf debugger. It is pretty much the exact same as C's printf. The difference is that its first parameter takes an Objective-C string rather than a C string. And also, unlike printf, it automatically appends a new line at the end. But other than that, it's pretty much the same as printf. You can do all the same format specifiers, specify the width of all those parameters that you pass into the format string. Objective-C also introduces a new format specifier for objects. It's %at is the format specifier for an object, so that means you can print out an object using that specifier. Under the hood, there's a method called description that it calls on your object to get the string value of that object, and then it prints that and it returns that. Yeah.
So, like, if you pass the object and this object descriptions all automatically called to print out the description.
Mm-hmm. Yeah, I think here's some examples. So, real simple NSLog is hello world. Again, let's assume we have a fraction class. If we want to write fraction equals numerator divided by denominator, we can ask the fraction for its numerator and denominator and pass those in as the parameters to this format string using %d because they're integers. If you're familiar with printf strings, that should be pretty obvious how that works. And then this bottom example is, I guess, suppose this is some array object, not a C array, but like an actual Objective-C object. Then this will print out whatever the description method of NSArray returns for that particular array. Okay, like was kind of hinted at, there are two other keywords in Objective-C. One is self, which refers to the current object. If you're a Java person, it's equivalent to this. We also have super, which is a reference to, allows you to get at the parent class's versions of your methods. So here's an example. If I want to get my age, I can ask NSDate how long it's been since my birthday. Or I can be 60 years older for some reason than whatever my parent would say. Any questions about self or super? They should be pretty easy. Okay, so I think this is sort of my last point, or almost my last point, is how to initialize Objective-C objects. And there's a pretty common pattern for creating an Objective-C object. And it looks like this. It's class name, there's a class message called alloc, and its job is to allocate space on the heap for your object. It doesn't do anything else. It just basically makes space and gives you a pointer to the space in memory that your object is going to live on the heap. Then there's a method called init, stands for initialization, which is where you actually initialize your object, set up any initial conditions on your instance variables. If you have any long-running tasks you need to start, you can start them there. But the idea is that the init is where your class is going to get going, and you set yourself up. If you omit either alloc or init, your object will not be will not be initialized correctly. So it's usually quite useful when you're defining a custom class to customize the default initializer. NSObject defines its own version of init. It doesn't really do much of anything, except maybe give your instance variables default values, like 0. So the common way to define an initializer is to override init. And the way you do it in Objective-C is you say, first, initialize myself as an instance of my parent. So that's why there's the super init. So that means that if my parent does any custom initialization, that gets taken care of by my parent, so that way I don't have to do that. Then there's this kind of funky looking if self. The reason they had that is there's a chance it allows classes. There's an object called nil that I think I'm going to talk about in a little bit, but it's kind of the nothing object, and the idea is if for whatever reason an initialization fails, it can return back as its value nothing. And then the idea is, so if for whatever reason my parent's initialization fails, I don't want to do any of my custom initialization, I just want to abort. So that's why we protect any custom initialization inside of this if-self block. You can do it without this. It's at your own risk. It's very, 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 very rare that initialization is going to come back nil, but it's worth having the check for. And so the idea is you initialize yourself as your parent, then as long as you've been initialized correctly, you initialize your state, and then you return yourself. Does that make sense? Any questions about writing an init? Yeah.
So if it is a nil, what should I do without doing that?
The conventional wisdom is if your superclass's initializer returns nil, you should return nil. And so this code here handles that. So if the value of this I assign that value of the initializer to myself. So if this returns nil, then the variable self is nil, and then I return nil. So that way I maintain the fact that that initialization failed, and I'll report that to whoever initialized me.
And so later on in your code, you should have your standard error checking that when you allocate an object, you always check to see if it's null, and if it comes back null, which means that the allocation failed. So anywhere up the chain, if it fails anywhere up the chain, this guarantees that whoever ultimately makes the call to allocate your object. If it fails, it's going to come back null, and it's not going to crash somewhere up or down the chain. It's going to come all the way back to you, and you're going to get a chance to handle that
Okay, some people like to shorten this to write it like this, to have that inside of the if check. Notice that this is a single assignment, not a single equals sign, not a double equals, but you don't have to do it that way. This is better. Do it this way. Okay, so I mentioned a little bit that there's this object called nil. Its Objective-C is nothing object. It's slightly different from null in the sense that it's actually an object. C defines null, which is just a 0 pointer. Nil is actually an object that's kind of the nothing object. So again, if initialization fails, it reports nil, saying that initialization failed. One really nice thing, or evil thing, depending on your opinion, about nil is that the nil object is perfectly happy to receive messages. Nil won't crash it if it receives a message. So unlike a null pointer, which would crash if you try to call a method on it, a nil object, if you call methods on it, will just basically fail silently. So in the case of methods that return a value, if you send a message to a nil, if you send such a message to a nil object, it will return back whatever the default value is for that type. So in the case of numbers, it's going to return back 0. In the case of objects, it will return back nil, and things like that. In the case of methods that don't return anything, it just fails silently, which is both a blessing and a curse. Because it's a blessing in that it doesn't crash, but if an object is nil and you don't realize it, and things aren't happening, it's kind of unclear why it's not happening because you haven't checked that the object's not nil. So it's nice in the sense that it avoids the need for a lot of exception handling, but it requires you to be a little bit more diligent in your debugging. And as I think I mentioned earlier, nil is one of those don't care parameters that some methods take if you really don't care what the parameter is, as long as you just give it nothing. Yeah.
Is there like some possible way to get the message or some error message, like you're sending a message to nil in some way?
I don't think there's a tool for that.
If I could jump in, a practical example for this might be, suppose you have a method that does something and then notifies another object. You might have your method call the new blah-de-da and notify this object. If you pass in nil and your code sends a message to nil, you can just have one line saying nil, I did whatever. You don't need to add in a bunch of checking to see whether it's nil, and you don't need to worry about throwing or crashing your program. It's useful if there's and there are situations where you might want to be able to get away with this.
Yeah, it's actually very convenient a lot of the time. Okay, so I hinted at this earlier, but Objective-C defines its own Boolean type. Its type is named bool. The values are yes and no. The reason it's yes and no is because objects are talking to each other using messages. So if I ask you a question, you should say yes or no. I'd say, yeah. It said, are you a man? False. No. A human would say no, right? Or whatever. So that's kind of the idea, is that it's supposed to be yes or no because you're talking like a message. But the value of yes or no, it's just pound defined to be 0 and 1, or 1 and 0. Okay, one last parting remark is just about a couple of conventions in Objective-C. So as you've probably seen in my code, the convention is to use what's called camel case, where you start with a lowercase letter, and anytime you have a new word, you just make that first letter capitalized, so that way it's not the C convention to use underscores or dashes like in Scheme or whatever. You might have been wondering why all the base classes start with NS. There's a convention in Objective-C that all classes that are in a related package should have a common prefix on the name of the class. The built-in classes have NS to begin with because all these were built at next step. And you'll see for the iOS, for the UI stuff, they're all prepended with UI, for example. But it's just a convention to keep names from clashing in case different packages define a class that has the same name but has different behavior. It keeps them in separate, prevents them from colliding. So I know that was kind of a whirlwind overview. Do you have any general questions about Objective-C? There's a lot more to cover, and we'll talk about that in the next couple lectures.
If you're defining it for a custom class, do you want it to return it or the class type?
It's actually perfect. So the question was, if you are defining an initializer, do you want the return type to be id or the name of the class? Either works. It's convention just to return id because that's how it's defined up in NSObject. The reason they use id is that the method is declared in NSObject. So if they wanted, they could have said the return type is NSObject. The problem with that is now that means every object, when it's returned from init, is statically typed as an NSObject, which means that you can only call NSObject methods on it and not your own custom methods on it. So id, because it doesn't really check what the type is, it just allows it to work with whatever class you want, as long as you would make sure that it makes sense. Good question.
Make it as restricted as you need it to be, because the static type checking is really handy. You can use it. I mean, it does come down to convention. I mean, a lot of people use it just as the default de facto. I like to constrain it as much as I can, just so I can get the benefits of the static type.
But either way works. Okay. Any other questions? Okay, so that's, I think, all I have for actual material. Before I let you go to the lab, are there any administrative questions other than the numbers?
We're working on getting the Piazza group set up. That should be very soon.
Okay, and like I said, if these numbers sustain themselves, we will open up more class time to accommodate for that.
Yeah, for today, we're going to use both rooms, and all four of us are going to be circling around like vultures. So if you have questions, raise your hand, and we'll be happy to help.
Okay, and then...
Sorry. If you got a red chair or one of the special chairs from in there, please, at this point, bring that back in there. You don't have to sit in there necessarily, but please bring the chair back in there.
Okay, and then a couple last things. If you please, I have the attendance sheets again, so at some point today, you don't have to come up right now, but at some time before you leave, make sure your name ends up on one of these. And then one last word, I have account forms for lots of people. If you have these machines are set up in kind of an odd way that you must have a CS198 account to actually build on these machines. So even if you have another class account and you want to use one of these machines, you won't be able to build your projects with it. That's just Xcode has some permissions set up like that. So if you think you're going to need these machines to build your project, come get an account form. And I think that's it. Do you have anything else, Juan?
Another logistical thing is that a lot of these labs were written with Xcode 4. Xcode 4 didn't make it to these machines during the break.
And it's rather different.
Yeah. So we've tried to list a lot of the changes to the labs that have to be made on the website for Xcode 3 if you're building things on here. Hopefully, intuitively, it'll make sense what some of the differences are, but if you have questions or if you're stuck on the lab, if there's an interface element that's missing, let us know and we'll help you out.
And we'll find it for you.
Yeah, we'll add it to the RAD page.
Okay, cool. So the lab's up on the site, so go ahead and have fun with it.